I am Anil Kumar. Welcome to my series on Radian measurements. We'll review few basic concepts which we need to understand before starting the topic. On this page, you see two things. One of them is parts of the circle. I hope you are familiar with this. Go through these different parts. A circle is basically defined with its center point, let's say capital O, and the radius r. So if you define a center point and the radius, you have actually defined a circle. Different parts of the circle include the radius, twice the radius is the diameter, a chord, a segment, which is the area in between the arc and the chord, and most important here, which we'll discuss more while talking about radian measurements, is the angle which is formed within an area defined by the arc. So this is the arc where we have defined an area, then the angle which is made by the arc in between, we call this as the subtended angle, right? So whenever I use the term which is, let me write down here, subtended angle. It really means this angle, and we'll name it as theta for most of the cases. Perfect. Now, for a circle, you know, diameter is twice the radius, so these are the formulas. The circumference C can be written as pi times diameter or 2 pi r. The area is pi r square, and full angle around a circle is 360 degrees. With this in mind, let's continue further. Now here you see two concentric circles. They have the same center. What you notice is that the ratio of arc length, this is the arc length, to, let us say, that's the radius, right? So what you'll notice here is that the ratio of arc length A over, let's say, A1 over R1 is equal to the ratio of the other arc and the smaller radii. So A2 over R2. That is important to understand. You get it because both are similar, right? We say that a circle has infinite symmetry. So this property of infinite symmetry will be utilized to answer many questions based on circle. To review, I have taken 10 multiple choice questions. Let's see these questions, answer them one by one, and then move forward. I would like you to pause the video at this stage, answer the questions, and then check with my solution. Now these are simple oral questions which you could straight away answer. Question number 1 here is, find exact value of circumference of the circle with radius 4 centimeter. So when we say radius is 4 centimeter, circumference C is 2 pi r. So we can always plug in the value 4. So we get 2 pi times 4, 8 pi is your answer, correct? So option D is the right option. Similarly, let's look into the next question now, which says, find exact value of area of the circle with diameter 6 centimeters. You can pause the video, answer the question, and then look into my suggestions. Now here we are given diameter, which is 6 centimeters. So from here we can find the radius. Radius will be half of diameter, right? So which is 6 divided by 2 or is equal to 3 centimeters. Once you know the radius, we know the formula for area, which is pi r square, and therefore the area will be pi times 3 square, that is 9. So 9 pi is the answer for us, which is option C. Clear? Let's move on and take the next set of 2 questions. Question number 3. Find radius of a circle with circumference of 10 pi. Now in this case, you may have to work backwards. We are now given circumference C, which is 10 pi. Circumference is 2 pi r. You need to find radius, correct? I think you can definitely find it. Rearrange the formula, so we get r is equal to 10 pi divided by 2 pi, right? So pi and pi cancel, right? 10 divided by 2 is 5. So you get radius of 5 units of centimeters. So option B is the right option. Question number 4. Find area of a circle with circumference of 12 pi. This time you need to find the area. You are given circumference C as 12 pi and you need to find area A, which is pi r square. Means you need to first find the radius and only then you can find what area could be. Now for a circumference of 12 pi, we know the formula is 2 pi r. So that gives you the value of r. So from here we can calculate what r is, just as we did in the previous question. So r is 12 divided by 2. 12 divided by 2, which is 6, correct? Now we know what r is, so we can find area, which is pi times 6 square, or is 36 pi. So the correct option is option D, 36 pi. Let's look into the next set of questions now, which is question number 5 and 6. So from here, the questions could be slightly difficult. Question number 5 here is, find length of an arc that subtends an angle of 60 degrees at the center of the circle with circumference of 48 units. You can pause the video, answer the question, and then look into my suggestions. So what I will do here at this moment is make a sketch so that we can understand what we're trying to figure out. So let's say we have a circle here, right? So let's say this is our circle. The question is, find length of an arc that subtends an angle of 60 degrees at the center of the circle. So what we really need to find is the arc length, right? So let's say this is one ray, that is the other, right? And let's say this angle is 60 degrees. What we need to figure out is this length. Let's say this is A. That is the question for you. So I hope the question is absolutely clear. Now try to find the answer. Find the length of the arc A that subtends an angle of 60 degrees at the center of the circle with circumference of 48 units. So we have changed the units from centimeters to just the number units. That's a shift in our approach, and this shift is going to help us understand radians as we shift from degrees to radians, right? The formula is circumference is 2 pi r. Now we are given that full circumference is 48 units. Now if we want only the periphery for corresponding to the value of 60 degrees, what should it be? Well, the full circle, as you know, is 360 degrees. From the symmetry of the circle, we can say that this should be 1/6, right? So from here we can say, well, the value of A should be equal to, in the same ratio, 60 degrees over 360 degrees times 48, means 1/6 of this, correct? 1/6 of 48, and that is equal to 6 times 8, so 8 units. Is that clear to you? So the option is B for us. So I hope the steps are absolutely clear. Now in this example, we are utilizing the properties of circle, which is its symmetry. So if you want to find arc length, which is a portion of a circle, then it is in the same ratio as the angle. That's the concept. Is that clear to you, right? So we'll use this concept moving forward. The next question here is, an arc AB subtends an angle of 120 degrees at the center of a circle with radius of 6 units. Find the length of the major arc AB, right? So let me again sketch a circle, and then we'll try to understand that concept, right? So this time let's take a circle. Let's say this is the circle for us. Now the question is that we are given an arc AB subtends an angle of 120 degrees at the center. So let's say 120 degrees. Let's try to make this. So this is 90. So maybe that could represent 120 degrees. Okay, so we are saying that this angle here is 120 degrees. Okay, and the points A, B, this is A for us and that is B for us. These are the 2 points, let's say A and B. An arc AB subtends an angle of 120 degrees at the center. Let's call the center as O, with radius of 6 units. So this is 6 units. So both are 6. Find the length of the major arc. So when I say major arc, minor arc is the smaller one. Major will be this arc. So we are interested now in finding out this length. Correct? How can you do this? So I hope the question is absolutely clear. Right? Now use your concepts of infinite symmetry to find the length A of major arc. Let's first find the circumference itself and then we'll figure it out. We know that the radius is 6, so we can say circumference C is 2 pi r. So 2 pi I'll multiply by 6, or is equal to 12 pi. So that is the circumference. We are interested in the major arc. Major arc means how much angle? Well, the angle will be 360 degrees, take away 120 degrees, right? So which is going to be 240 degrees. So the portion of the arc which is corresponding to 240 degrees is our answer. And therefore, we can now write down our answer A as equal to 240 over 360, right? It is in the same ratio, times the circumference, which is 12 pi. Is that clear to you, right? So that is the length of the arc, which is the major arc for us. We can simplify this. 12 goes 3 times, and dividing 24 by 3 we get 8, and so the answer is 8 pi. Option C is the correct option. So many steps are now involved when we solve such questions, and that is why I am putting them into extended applications. So I hope the steps are absolutely clear. What we did was we first found the circumference, which is the total periphery of the circle, then the angle corresponding to the major arc. The ratio of the angle to the total angle gives us the arc length in this case. Perfect. 7. Find area of the sector of a circle with subtended angle of 60 degrees and radius 12 units. 4 options are given to you. I'd like you to pause the video, answer the question, and then look into my suggestions. Let's try to understand the question first. So I'll just sketch a circle here, and from there we'll correlate. So here is the circle. We're saying find the area of the sector of a circle with subtended angle of 60 degrees. What does that mean? It means that the angle between the two is 60 degrees. That is how it should be, right? So what we have here is that's this 60 degrees angle. And when we say sector, we are interested in this portion which I'm shading. Is that clear to you, right? So that is the sector. It says find the area of the sector of a circle with subtended angle of 60 degrees and radius of 12 units. So the radius in this case is 12 units. Thus the center is O. We need to find area of the shaded region. So what we can do here is find area of the circle first. So area of the circle is pi r square, radius is 12, so it is pi times 12 square or 144 pi. Since we are interested in a sector which is corresponding to 60 degrees, we can say area of the sector is 60 divided by 360, right? Because total angle is 360 of 144 pi. That comes straight from the symmetry of the circle, right? So I hope this step is absolutely clear. Now, we'll simplify this. We can cross out, simplify. It is 6 times 6 is 36, and dividing 144 by 6 gives us our answer, right? 6 goes 2 times, which is 12. 24 is 6 times 4, 24 pi. So the option D is the correct option. So I hope the steps are absolutely clear. So what we again utilized is the concept of symmetry, right? So we say infinite symmetry. And therefore, we could work with ratios as it has been shown here. Question number 8. Find length of an arc that subtends an angle of 45 degrees at the center of a unit circle. Now, here's a new term for you, unit circle. Unit circle means what? Let me write circle like this. Unit circle means that the radius r is 1 unit. That's what it means. So we are in a way given the radius. The question is find length of an arc like this for a unit circle. So that means if I sketch a circle, let's say here we have a circle. In that case, this circle will have 1 unit as the radius. So this radius is 1 unit. And we are saying subtends an angle of 45 degrees. So 45 degrees kind of like this, right? So you can say this angle here is 45 degrees. We need to find the length of the arc. So we need to find this length. of the arc which subtends an angle of 45 degrees. Is that clear to you? How do you figure this out? Well, this is 1/8 of the whole thing. So what we can do is we can find the circumference. C is 2 pi r. R is 1. So 2 pi times 1, which is 2 pi. So circumference is 2 pi when the radius is 1. Now, the arc length will be how much? Arc length will be in the ratio. So 45 degrees is the angle against 360 degrees, which is for full circle, of 2 pi, right? So of 2 pi. So that should be your answer. So this is equal to 1/8 of 2 pi, right? So 45, you could simplify this, half, quarter, and this is 1/8. So 8 times 45 is 360. So it is 1/8 of 2 pi, or could be written as 4 pi. So the arc length is 4 pi for us. 1/4, I'm sorry. 1/8 of 2 pi is equal to, let's just push this page a bit, equals to pi by 4. So pi by 4, which is option A, is the right answer. So I hope the steps are clear. Again, we have utilized infinite symmetry of a circle, and we have taken ratio of what angle is of our interest against 360 degrees, which is one full circle angle. Now we are almost at the end. Question number 9 and 10. Question number 9 here is, find length of an arc that subtends an angle of 120 degrees at the center of a unit circle. So again, we are working with unit circle. So as is clear to you, when we say unit circle, it means radius is equal to 1 unit. We need to find length of an arc. So whenever we want to find length of an arc, let me highlight this. We have to look into the angle and figure out the ratio. So first step here is to find the circumference, C, which is 2 pi r. For a unit circle, circumference is 2 pi. I hope now you have captured this. Last example also, we got the same answer, right? Circumference is 2 pi for a unit circle. Now we need to find the arc length where the angle is 120. So arc length A for an angle which is 120, circumference is for 360, right? So it will be ratio of 120 degrees to 360. Full length of 2 pi circumference. Now that can be simplified, and 12 goes 3 times. So we get 2/3 of pi as our answer, right? So 2/3 of the pi is option C. So do you see how we are utilizing this concept of symmetry and using ratios to find the arc length as related with the angles? Now this is a huge concept. When we talk about radian measurements, most of the time we'll be working with this concept. Now building on this is question number 10, which is the last question of this video, and then we'll have one student's activity. Question number 10 here is, which of the following statement is not true? Is not true for a circle O of radius r? A. Circle has infinite symmetry. B. If the radius is doubled, then the circumference doubles. C. For twice the arc length, angle subtended will be twice the initial arc length. D. For twice the subtended angle, the arc length will be twice the original arc length. E. Area will not be twice the original area if the radius is doubled? Very interesting question. I would like you to think about it and answer. It seems as if all 5 are correct. However, it's a bit tricky question, so think about it. Here, let me sketch a circle for you so that it becomes easier for me to explain the solution, right? So here is a circle for us. We have all the conditions. The condition which is not really true is which one? For twice the subtended angle, arc length will be twice the original arc. So that is the answer for the question. Can you tell me why? Okay. So the interesting part here is that in a circle, arc length is maximum circumference, right? So we have the maximum arc length equals to circumference C. Is that clear to you? Now what happens if I have a reflex angle? So if I have a reflex angle, let's say the angle greater than 180 degrees, in that case what happens? There is a major arc, right? So double the major arc will be more than circumference. Perfect. So then it is not true. Correct? It is not true. So this is the only statement which is not true. So for twice the subtended angle, arc length will be twice the original arc. Now, here is a condition, and the condition is only when angle, let's say theta, is between 0 degrees and 180 degrees. Only then it is true. Otherwise, it is not true. Perfect. So I hope you have understood the concept. And here is the last question for you to work on, and that I'm treating as student's activity. The question here for you is, find the angle in degrees in a unit circle for which the arc length is 1 unit. All right. So with that, we come to an end of this particular video. You have already seen few interesting parts dealing with unit circles. Means radius is 1 unit. The angles which we came across were in terms of pi. Do you see that? 2 by 3 pi. And the answer of previous question was also in terms of pi. We had pi by 4 answer here, right? Do you see that? Pi by 4. So in a unit circle, the angle is normally in terms of pi. Therefore, in this case, what I've done specifically, I am saying find angle in degrees. In a unit circle for which arc length is 1 unit. So the question is, A is equal to 1. What is theta? In degrees. Perfect. So I hope you find it interesting and useful. Feel free to subscribe to my YouTube channel and be a member of this very dynamic group, Global Math Institute, where we are providing a lot of free videos, well organized, for you to understand any topic in mathematics better. That's the whole idea. Follow this series where I'm going to take up multiple choice questions, set of 10 most of the time, followed with students' activities and worksheets for you to practice. I hope you find it useful and interesting. Feel free to write your comment, share your views. Thanks for your time, and all the best.